All right. Thank you so much, Sylvia. Fantastic stuff. And we got one more thing that we need to get through before we, get to our next panel. I'd like to welcome up Mike Moreau, who's on our AS Board of Directors, just to say a few things. Mike.
Okay, thanks, Jim, and hi, everybody. I hope everyone is energized about some of the discussions we've seen this week and some of the conversations that we've had at the breaks, as I have been. Events like this really foster, the opportunity for participants to exchange ideas and, in a way that's not possible in our daily routine in our, individual organizations. And that's something that the AAS brings to our community is the opportunity for this kind of exchange and information sharing, and we hope that that's a great value to the members. So a lot of you, if you participate in our meetings and symposium, you may not or think a lot about the behind the scenes of what it takes to do that. I'm here today as a member of the AAS Board of Directors. There's an executive committee and an elected board that essentially shepherd the organization. It's a small, dedicated staff. And so the board members and executive committee have an oversized role in chartering the future of the organization and making progress, for the future. So I wanted to talk to you really briefly just about a couple of things that are opportunities right now and something that's coming up on the horizon. So first of all, I'm going to be chairing the AAS Awards Selection Committee this year. The awards call is open. The nominal deadline is this Friday, October 31st. If you are considering an award, and I highly encourage you to do so, there are 11 different categories that are open. This is another thing that AS does for the community, is provide the opportunity to recognize your peers and teams for their accomplishments. So I highly suggest for you to visit astronautical.org/awards, and you will see the award descriptions and the process there. Given the deadline is the 31st, if you're considering a nomination and you need a little more time, please reach out to us through the website. We know with the government shutdown, that's suppressed, the time people have had to work on stuff. So please reach out to us, and we'll work with you on getting that nomination package in. The other thing I wanted to mention that's open now is a call for fellows. Are there any current AAS fellows in attendance today? Could you raise your hand? Anyone? Okay, we have at least one. So there are a number of distinguished individuals in the audience that I've talked to here today. Look across the community and think about who else might deserve to be recognized as an AAS fellow. That call is now open through November 21st, and we really want to have some quality nominations. It's a very distinguished recognition that in the community, and encourage folks to think about nominations for that. Finally, I've been privileged to serve on the AS board for the past 3 years. My term is coming to an end, but I'd also like to challenge folks to think about perhaps stepping up and considering serving on the board of directors of the AAS. This is, if you have interest in doing that, I guess I'll ask for audience participation again. Can you raise your hand if you are a current or former member of the board of directors or on the executive committee of the AAS? So we have several people here. If you could keep your hand raised for just a second. I'd encourage you, if you're considering you'd like to have some involvement with the AAS, seek out me or Jim or one of the folks that has their hands up here and ask them what it entails. It is not a huge commitment, but you can have a big impact on the future of this organization, the kind of topics that get discussed in forums like this, and how is AAS going to respond to this dynamic and changing environment we have right now. You can be a player in that and really give a lot back to our community. So please consider that and talk to me if you'd like some more information. That's all I had. Thank you for your time and attention.
All right. And now we're getting into our next session. So let's get the panelists up here. Grab your seats. And like we said, this one's a little different. We're without a moderator for this one. So again, like Sam said, you are the moderator. So we've gotten a bunch of questions already, and we've got Sam and Macy are going to be here and helping out. Sam, do you want to say something? But we'll turn it over to you.
So thank you all for participating in this lottery selection for questions. So I've been doing this for many of you, for some of you, for a few of you, I've been doing this for 38 years. And so you've heard from me plenty. So we're going to allow this to go to the next generation. So Macy, come on in. So Macy's going to be doing the question reading and selections, and we're going to take it from there and just see what kind of thoughts you guys have to read this panel as you, the moderators. So thanks for your input.
Yeah, and Sam, we are going to go and introduce ourselves, and I think we each have a couple of slides. So we'll do that, and then we'll get into the questions.
Yeah, you get 30 seconds no matter how long it takes.
Got
okay?
it. Cool. Got it. Can I have the clicker?
Risk it.
All right, hi. Hi, everyone. I'm Tim Cichan, Chief Architect, Commercial Civil Space for Lockheed Martin. And I've been in this role for about 10 years. And then prior to that, I spent 10 years on the Orion program. And as I was looking at Kirk's charts of the family photos and looking at the photos of Artemis 2's fully stacked in the VAB, I've seen that in our CAD diagrams and our visual comms, pretty pictures, graphics, but it's all real hardware about to fly. And it's in production and about to fly, and that's pretty exciting. And then I started in geosynchronous communication satellites as a trajectory guy, where we always, to get an FCC license, had to have enough fuel to retire above geo. So I really appreciated that orbital debris talk. It's very important to be, I'll use the word responsible. So the panel's going to talk about lunar infrastructure, both in orbit and on the surface. And Kirk flashed this up, but this is a short story white paper that we released last year. You can go to the QR code and download it. And it's set in roughly the 2040s, and we decided to use a story of a commercial astronaut and a pressurized rover driving around, maintaining the infrastructure on the lunar surface to talk about our ideas of what we need. And so things like power and communications and navigation and landers and rovers and roads and berms. And it kind of explains how that might look in a very commercial environment in the future. And it ends with a description of electromagnetic launch. We've actually had some technical papers on that as well. We're a big proponent of water ISRU and producing propellants. But you end up burning a lot of propellant to launch propellant into orbit to get propellant back to LEO. And so we've looked at concepts for electromagnetic launch, and certainly with fission surface power being at 100 kilowatts coming soon, there's plenty of power for electromagnetic launch. And one thing I did want to cover is the term economy. An economy ideally starts with a product that lots of people want to buy. But it doesn't always work that way, especially in environments, extreme environments like the lunar surface, but even in newer environments where we have to start with the infrastructure. So start with that gray layer. And that's what we're going to talk about today. We're going to talk about, well, what infrastructure is necessary and how does that work? But the point here is a lunar economy. And so we need to move down from infrastructure to a production economy to produce that product. Now, I've talked about water ISRU and making propellants, but there's also folks talking about data as a product for the moon, whether that's science or other data, talking about aluminum and silicon. Maybe that will be the materials for in-space factories of the future. And then once you've got that pyramid built, then there's certainly some fun stuff at the top, the tertiary things like additional tourism, permanent presence, and supporting Mars exploration. So this is definitely a long-term vision. So we'd like to have that vision set so we can talk about the steps today to get to here, starting with Artemis 2 as early as February.
Well, thank you so much. I All right, I'll move on to the next topic here. So my name is Jeff Parker. I'm the Chief Technology Officer at Advanced Space. And I know there's a lot of students in the audience, and I'm really talking to you. And some of those students might be, 60 years old with a lot of passion. So I'm talking to the people who are young at heart and interested in space exploration. So we as a company started not too long ago, and we started with a small number of people. And we were challenged with identifying low-cost solutions for high-value missions, partly because it takes low cost to establish those economies of scale and whatnot, and to build on those. And so grad students fresh out of college have an opportunity to fly spacecraft. And I try very hard to make sure that those grad students that are coming straight out of college have a chance to do that and see what it's like to fly the spacecraft so that they have an understanding and appreciation of what it takes to do these things. So it's really exciting. So I have a couple charts here. And I wanted to say our company, Advanced Space, is focused on enabling the sustainable exploration, development, and settlement of space. And that covers, going out to the moon for the first time in our company's career, but also settling. And settlement involves quite a lot of infrastructure and technology. So fun little study on that. We were challenged to support ESCAPADE. ESCAPADE's the next Mars mission on the launch pad. It's fingers crossed if weather permits. It's scheduled for on or about November 9th, looking at the weather. And it's a mission that is 10% of the cost, carrying on the legacy of MAVEN. And it's in the Simplex. So along with Janus, Lunar Trailblazer, ESCAPADE was selected as part of Simplex. So very low cost. The original budget was $55 million. So, we were challenged, how small could you make a spacecraft bus? How small could you make this thing? And use that, as a ground rule for developing a low-cost mission. And we learned pretty quickly that at Mars, the communication system really dictates it. So if you have to communicate from Mars to the Earth over this vast landscape of spacescape, it takes a large communication system, takes a lot of power, and that really quickly dictates the minimum size of the spacecraft. So we tried to challenge ourselves to get down to really small, 100 kilograms or less. We settled, and it has evolved to about 530 kilograms per spacecraft, which is a small Mars spacecraft, much smaller than MAVEN. But if there was a communications hub at Mars, then that whole communication system gets smaller, the power system gets smaller, the amount of fuel it takes to push it around gets smaller, the whole thing gets smaller, and you can now attack this at a much smaller scale for low cost. So, I bring this back to these experiences of trying to pave the way for the future. Our company has been focused on robotic establishment of space infrastructure. So I love that these guys are focused on the ground, establishing fission. I love the number, 100 kilowatts. Yep. That's amazing. We have like 100 watts. So if you have the communications, the positioning, the navigation, the timing set, then the cost of fuel and infrastructure needed to get the infrastructure to the ground is going to go down. So that's how we're focused, and one of our first missions has been Capstone. So I've got a couple charts on Capstone and how Capstone is working on demonstrating new navigation technologies. So the traditional way of communicating and navigating is shown in the top left here, where it's like everything is talking to the Earth. Everything is devoted to your deep space network or other antennas. In the top right, I'm going to point over here because that's what I can see, but in the top right is the smallest piece of a satellite-to-satellite communication and navigation system you can come up with, just two satellites. And that's what Capstone is doing. Capstone is communicating with the Lunar Reconnaissance Orbiter. Funny story about that, LRO was built way before Capstone was even a blink in our eyes. So we had to fly a radio that is a reverse radio to the LRO in order to communicate and navigate with LRO. And Capstone is working on a vision where navigating 100 spacecraft at the moon, there's a lot of different ways you can do that. One is optical navigation, one is this crosslink, the satellite-to-satellite navigation, and then another way is just to transmit beacons towards the moon, and you have any satellites that receive it pick it up. So all these different navigation technologies are being tested out by Capstone. This is the acronym of Capstone. It starts with the Cislunar Autonomous Positioning System, CAPS, and then the rest produces a pretty cool acronym. And CAPS, the vision that we had was that if you have multiple spacecraft at the moon that all have navigation requirements, that they can share the load, and by doing crosslinks, you can get a lot of really terrific orthogonal communication pathways than you would just by focusing all the communications from the Earth. And it also takes a lot of the burden off of the Earth assets, like the deep space network that are overtaxed. So we've been understanding that, trying to understand it, and that works really well for the far side of the moon when you don't get any Earth assets as well. CAPS is it scales trivially, so the more satellites you have, the more opportunities you have to talk to other spacecraft. And so we really like this strategy for establishing infrastructure, because every mission that flies to the moon can just add to that architecture. So we heard from Intuitive Machines, working on developing a position navigation system too. I think my own objective is to see that they are compatible so that they can all work together and establish a better infrastructure to enable 100 kilowatts on the surface of the moon. Mission summary real quick, and the chart's a little far away so I can't read it, but I can memorize it. Tom here is our project manager for Capstone. We've been operating for 1,000 days in orbit about the moon. Is that right, 3 years? A little more than 1,000 days now. Awesome. And then we completed the primary objectives, and so now in the follow-on objectives, we've been able to use it as a test bed for continuing the technology and even testing out autonomous navigation operations on the spacecraft so that the ground is not even in the loop at all. And then, because we're all nerds at heart, I had to show something that was a little more nerdy. And so here you can show the animation of the Capstone spacecraft flying over the moon, as close as Capstone gets to the moon, but LRO is right at the surface of the moon. And if you just navigate the two spacecraft, only using their navigation beacon back and forth, how well can you navigate another spacecraft? That alone isn't as good as the Deep Space Network, because the Deep Space Network is pretty amazing. But you can actually fly the spacecraft using just that navigation technique, and it's typically good enough for your operational requirements. So little nerding out on that one, which is kind of fun. And then I have another little graphic about Capstone, because we're all passionate at heart as well. So I'm looking forward to the Q&A and taking on the questions. But since I'm talking to the students, internship applications are due in about a week, so get those in.
And I don't know if the organizer realized this, but all three of us are from the Denver Boulder area, which has a lot of capability. And so Lockheed Martin designed, built, and flies Maven and Odyssey and Mars Reconnaissance Orbiter, which are the current infrastructure at Mars for communication. They're dual purpose. They're science spacecraft, but they're also how we get to talk to Percy and Curiosity.
And actually, to add to that, the Electra has been such a fantastic proving ground. Electra radio, it's a UHF radio that does this. It's been a perfect proving ground for why you can get a rover on the surface and get the data back, which has been just a perfect proving ground for that infrastructure.
And for another connection, we built HiRISE, which does all the imaging on Mars. So hi, I'm John Troeltzsch. I work for BAE Systems, formerly Ball Aerospace, where I've been working for over 40 years now. So I was involved with the repair and upgrade of the Hubble Space Telescope way back in the day. Then I worked on sending 1.5K superfluid helium into deep space for the Spitzer mission. As a company, we've just finished the alignment of James Webb. Just finished it, a year and a half ago, and good example of doing remote operations of very complex systems. I led our commercial lasercomm group for a few years, working on high-speed feeder links as well as crosslinks for low-cost crosslinks. And finally, about a month ago, we launched 2 satellites to Earth-Sun L1. To monitor the sun in real time, and also to look back at the Earth and look at how the sun's energy impacts the exosphere of the Earth, which is an experiment that's really never been done before. So we've done things from very large, including manned space, to to remote small sats at L1, which is really an interesting, you talk about sending small sats to Mars. It's kind of fun to send something that small 1 million miles from Earth. So I wanted to summarize, kind of our vision of an earlier phase of the lunar infrastructure. So this would be 2030, 2035, somewhere in that realm. First and foremost, I think about how to get cargo to the moon, right? And we've seen large lander systems, but I think there's also going to be a demand for a shuttle, a tug, a way to remotely move cargo from low Earth orbit to some point a staging orbit around the moon. That way, that vehicle can be optimized for the transport of hardware and not have to have the burdens of being launched over and over, from the low Earth orbit. From the Earth, or do the landing job. So that lander comes in to move the cargo then from the stable parking orbit down to the surface. And at that point, you start to develop up the infrastructure. And we've been looking at the power distribution system. I like to look for terrestrial analogs. So, what can we use from what we see every day in our lives to help develop power distribution systems and monitoring systems on the surface? Obviously, there's a lot of other challenges, but at the core, you've got power generation, power storage, power distribution, and you have to do that reliably and safely. Fusion surface power obviously really opens that up. That's a big job, and so we may have to have supplemental power in the interim, or in the staging part of getting that reactor up and running. You mentioned PNT and secure communications. I think we're all aware that we're going to require encrypted secure communications at least some of the time for the operations that are occurring on the moon. LaserCom is a perfect way to do that. It's very localized and provides a highly secure link, and is now becoming, I'd say, almost commonplace. For the PNT, again, I'm looking for terrestrial analogs. I help manage a farm in Nebraska, and we distribute GPS locally. So there's a repeater that captures a signal, could be any timing position signal, and redistributes it over a small scale, 4 to 5 square miles. Much simpler than putting a whole bunch of satellites in orbit, and it gives you that same accuracy you would require otherwise. I also have been thinking a little bit about localizers in small airports. As the landers come in, having a landing system is an important aspect, and that involves both support and guidance as the lander lands, as well as the infrastructure under the lander to prevent the regolith from being thrown up in the air. So what does that infrastructure look like? And how do we support that in preparation for the big landers starting to come in? Finally, I'll just mention environmental monitoring, remote rovers. We've got a package that's called Lunar that's headed for the moon on Eclipse. I think it'll be very important for us to have remote-controlled rovers that can go out and look at subsurface conditions, can monitor the radiation, and also give us a thermal signatures, right? So there are things that are very hot, very cold, and also that can help you understand what it is you're looking at. Speaking of radiation in the previous talk, it's interesting, during solar min, the cosmic radiation is at its max. So in 2030, we're going to be looking at a lot of the cosmic radiation versus the radiation coming directly off the sun. So the astronauts have to be prepared to monitor and encounter and react to each of those. So with that, I think we'll move into the Q&A.
What lesson about existing acquisitions can accelerate collaboration for operational infrastructure? Some examples here are CLIPS, Lunar Terrain Vehicle, PRISM, and ISS.
but I have a personal example on Vader, which is a similar one, but Vader was the one that Escapade used as a launch contract in order to establish a rideshare. So originally Escapade was a rideshare with Janus, and both of them were rideshares with Psyche. So Psyche was the prime. And for relative orders of magnitude, Psyche was a huge budget, fantastic mission going to the Psyche asteroid, and Janus and Escapade were high-value missions. It didn't carry a whole lot of weight on that one. And so in the Vader contract, there was nothing stipulated in there about how the rideshares could respond or would respond or had to respond if the primary launch vehicle changed its targets. And indeed, Psyche changed its launch targets a variety of times, and at one point, all the subsystems, all the secondaries could hang on for some amount of time. Eventually, both got demanifested because the launch targets changed substantially. You might remember Psyche launched about a year after it was expected to. And so the lesson on that one was that the Vader contract, didn't foresee that, and it's okay. I mean, we weren't expecting that, but it was a good thing for us in the room to be prepared for that sometimes these ride shares, to reduce the cost of things, have to respond to unforeseen changes. So that was one lesson.
Yeah, and we had the Janus spacecraft on that mission, and so it was going to go visit asteroids, and when the launch moved by a year, the trajectories didn't work. Right. And so those spacecraft are on the ground looking for a mission, hopefully one soon. I think another lesson that we're seeing, particularly with CLIPS and also with HLS, is that as you stand up new capabilities, it might take a little bit longer than you thought, and it might not be as successful as you thought at first. And I think that's okay. We just need to be aware that there's lots of things that we need to learn, but we have to keep going, and we have to be flexible and adjust as we learn from early failures what needs to be improved in the next endeavor. I think there's programmatic and contract things that I think we're learning on CLIPS and HLS, and I think there's technical things as well, and hopefully more folks will be following Firefly's lead in getting to the surface.
Yeah, in terms of lessons I'd like to add, we're looking at PRISM now, and these programs are to some extent stovepiped. So I'm looking for opportunities where we can bridge between the pure science or the pure human lander side of things. And I think that'll take some restructuring at NASA to start looking at maybe the broader scope versus one specific area like science. For example, right now we're looking at opportunities for doing tech demos. PRISM looks great for doing science demos, but we need something of that scale for tech demos as well. That'll open things up like it has for the academics in science, for some of the small companies and the entrepreneurs to be able to get hardware onto the surface and do tech demonstrations, basically.
No promises. All right. What are the key infrastructure that government needs to lead or provide in order to ensure a robust economy?
Yeah, so I think that from a government perspective, the public-private partnerships need to be structured such that the infrastructure is there for companies to make a profit in the future. And so for some things, once, say, there's fission surface power on the surface and there's a power grid around the Artemis base camp, there's a whole set of opportunities that can happen. And in the beginning of infrastructure placement, there's a lot of risk there. Risk that from a technical point of view that everything will work, and risk from a business point of view that customers will show up. And so I think government's best role is, hey, when there's an area of high risk, to do something to get capability on the surface, move past that risk, take on some of that risk, such that it can flourish. And that doesn't mean that the government needs to own and operate a power plant for 30 years on the lunar surface, they can transition that to a commercial partner. But it's really that risk that you can't close a business case around where I think government has the biggest role.
I think the only thing I would add is that I think the government provides a role when the capital investment is beyond what the commercial companies can manage all by themselves, at least without the risk. And so I've been pondering in my head, where is that capital investment best suited? And I'm willing to hear other ideas, but one idea has been on the launch, establishing a launch, and I can imagine a commercial company organizing a shared launch, but so far the Vader contract was a good example where they provided an opportunity for commercial to ride along with a launch and kind of share the cost of that and bring it down to the level where the commercial company could make money, and until the infrastructure got spun up a bit. So that was my one add on that.
So back to my terrestrial analog, think about the 1930s and you're pulling power for the first time to a house, or you're adding in a telephone. That's the kind of stuff that governments do pretty well, especially when you're starting out. And it provides an enabler for anybody that happens to be needing those services. So I clearly think the government needs to play a role in providing those basic infrastructure services up until they can be supported by other commercial entities or turned over. The other area I think the government can help is setting standards. We have Androids and iPhones, right? We really need to make sure that the systems are compatible, the power system's compatible, everybody's working on the same frequency, at the same voltage, that you can reliably plug something in and know it's going to work because you're a long way from home, and you're not going to get another one easily out of stores. So I think that setting up basic infrastructure as well as providing some standards and guidelines for how the infrastructure will be connected together is a great place for the government to help.
Yeah, and I think it's also nice that we can see the results from previous infrastructure investments. So on ISS with CASIS, helping to fund scientific experiments going to ISS and being performed, we saw that there's a market there, both a commercial market and I'll call it a science market. And that's what allows commercial LEO development to be a reasonable thing as a next step. We also saw it in technology transfer, say from the Orion program to the Commercial Crew program in parachutes and heat shields and other things that NASA learned and provided their expertise. So we see that in LEO, and we're really looking forward for it to happen at the moon.
I've got one ad to go along with it was a good suggestion. In the world of academia with the students here, building an algorithm is pretty challenging. It turns out flying the algorithm is another level of challenging. So what I showed with the CAPS technology, the notion of satellite to satellite navigation, what information is there? The algorithms all demonstrated that it would be successful. Turns out there are all kinds of challenges in flight. One of those was getting a license through the FCC to operate at the same frequency as the existing Lunar Reconnaissance Orbiter, because the FCC was making sure that we didn't interfere with the LRO, but we had to talk to the spacecraft that was already there in order to do this. And so it was a big hurdle, actually, to get a license with the FCC to talk on the same frequency. Memorandums of understanding and everything. So I agree with that.
Got it done.
Yeah, we did.
Yeah, I don't know about you guys, but getting to the moon and realizing that my, my Android phone doesn't work with a lightning cable would be a real bummer. All right. Is there an opportunity for specialized space or lunar manufacturing? What products could be made?
Yeah, so I think there's a number of different products. So we're a big advocate of producing propellant, which is certainly a product. I think there's also lots of folks looking at lunar regolith without changing it or without changing it much, to be able to do things like build a road or build a berm around a launch pad so that when the landers come in, they're not spewing regolith, sandblasting, everything else. I think that there's discussions about helium-3, particularly for quantum computing, which is something I wasn't aware of until recently. But I think beyond the propellant, I'm very excited by the idea of being able to make silicon and aluminum out of the regolith, because that means that now there is, a materials needed to build spacecraft available on the moon. And the moon's got it's a smaller gravity well than launching from Earth. If we can get over that point where some of the materials are coming from space to be able to make spacecraft back in Earth orbit or in cislunar space, I think that really changes things. And that's one of those hurdles that we need to get past, and it's going to require all the infrastructure like power to be able to do these factories in space.
I guess I'll add, I was talking to one of the students on break and was very curious about additive manufacturing and making things in space to use in space. So, it just folds right in. If you had the basic ingredients, you really open it up for the next generation and the entrepreneurs to decide what to make in space versus us trying to sit here and decide how you're going to make money in 15 or 20 years on the surface.
A little of the same vein. What are the current technology gaps to enable long-term surface living? So kind of flipping over to expecting humans to be on the surface at some point.
Yeah, well, I think the first technology gap is having large enough lunar landers be able to take large things to the lunar surface. So, of course, we talk about taking the crew itself in a very human rated and safe way. But also with the humans comes a certain amount of logistics that needs to be landed. And that exceeds what the CLIPS landers are capable of. So, and certainly the HLS landers have cargo variants, but we want to get to a very sustainable and reliable and diverse set of supply chain, like we have at ISS today, where we've had the Europeans, we've had Japan, we've had SpaceX, we've had Northrop Grumman. I see that type of future for the moon as well, now for larger cargo. And I think we also want to be able to produce power on the surface, and also, water is good for rocket fuel, but of course, breathing oxygen and drinking water is part of it. And then longer term, and I've looked at this from Mars as well, the food for the crew is heavy, and it's a pretty high volume. And so someday it'd be great to be able to be producing food, and I think that'll be really helpful. All of these things that I'm describing, we want to do it for the moon, as we are also thinking about how we're going to do crew to Mars.
So I'll add, I think everybody agrees it's going to take a lot of hardware to get to the moon, a lot of hardware to move that to extend that to Mars as well. And while we're not a hardware company, so I can't really chime in too much on the hardware itself, except I know it's a challenge, and there's a lot. What we're trying to do is reduce the cost of the fuel, reduce the cost of the complexity, reduce the cost of the risk to get all that hardware there. So traditionally at the moon, if you really try to map out the moon, there are opportunities to land at particular places on the order of a week per month. Traditionally, if you take a traditional path that takes, like, say, 4 or 5 days to get to the moon, if you follow a low energy transfer, it takes 3 or 4 months to get to the moon, which a lot of conventional wisdom says that sounds expensive, that sounds high risk. But I can advocate that Capstone was successful because we had 3 or 4 months to get to the moon. We could respond to issues. All these are going to be brand new spacecraft, and anytime you have a brand new spacecraft, there's little issues. Capstone had its issues, and we had time to work those issues because we took time to get to the moon. In addition, it reduced the cost of the fuel. So Capstone and Grail are two examples where the missions were enabled by taking a longer path to get to the moon. Maybe not the best for humans, although I would advocate that humans ought to consider flying one of these 3 or 4 month transfers to the moon before they go to Mars, because you kind of get a stepping stone practice on what it takes to be committed to a Mars mission. But for the moon, these low energy transfers, you can launch anytime and get anywhere, but it takes 3 or 4 months to get there. So you can open up any launch pad and you can launch on any given day to get to the moon, which is exciting. Escapade is demonstrating how to do that for Mars, and you'll notice that in 2 weeks, Escapade is launching and the planets are not lined up. They're a year away from being lined up. And so Escapade is paving the way on how do you do that for Mars? How do you have the capacity to launch any day and get to Mars, and therefore send a fleet to Mars to get the colonization hardware needed there using a relatively small number of launch pads. So that's another exciting bit.
So I've been thinking about the ratio of robots to humans, right, on the moon. And I would expect that there's some study that could actually suggest what that number might be. But if you look at what's happening with robotics on the Earth, you know, whether it's an Amazon factory, whether it's UAVs, whether it's unmanned fighters, you know, there's a lot going on there now, and it's a force multiplier. So if we're going to spend the money and get the astronauts to the moon, we should also consider what it takes for them to be have maximum productivity. And I do think that's in the robotics area. And I'm not even sure we've thought through completely what kinds of robots and what they should look like to operate in a lunar surface environment. It's certainly not like anything we're used to, I think.
Yeah, I think that ratio is going to be pretty high. Much more robotic autonomous systems than humans. And I think those systems will also be flexible in that they can operate autonomously. If they have a problem, a human can remote in and teleoperate some problem. And then if it's a really big problem, then the humans can go there. I think also as we move to sustainable operations, logistics becomes more and more important. Like your point about low delta V trajectories. You know, if you're just going to send a couple of things, you can make it very time critical. But we want to set up a production system of logistics to and from the moon long term, and we're going to have to really dial in the efficiency.
Perfect segue to the next question, so nice work. This is more so regarding logistics at the surface. How would you propose solving the issue of local lunar ground transportation of logistics, supplies, equipment, and crew across various landing sites?
Yeah, so I think, right now, the LVTS, the unpressurized crew vehicle, and then the pressurized crew vehicle, I think for the crew part, we're pretty well set up. And depending on the power infrastructure that's there and the capabilities of those vehicles, they'll be able to move long distance. The more interesting question is, from a logistics point of view, how are we're going to move stuff around on the moon, and how much do we have to move stuff around? How close can we be landing? Do we need to have a dedicated launch pad, those sorts of things? We have a contract from NASA, a Next Step Appendix R, that's looking at all of these logistics issues, including the mobility parts. And I think again, we're gonna need a diversity of systems of different sizes and different capabilities to be able to have that strong logistics supply chain.
So we just moved 2 satellites to Florida to launch, and what we used were trucks and forklifts and cranes, right? And again, I don't know what those analogs look like on the surface of the moon, but you're gonna need that mechanical assist of a forklift. You're gonna need the ability to lift heavy objects like a crane. You know, that doesn't come on day one, but it's gotta come fairly soon after the logistics needs start to arise. So it's kind of interesting. I mean, it's almost in the land of sci-fi to think about what some of these things might look like. And we've been doing sci-fi for a long time, so maybe there's some examples there.
Add a little bit more too, because these things have to be robust, reliable, low cost, And we've been seeing the cost of launch coming down, and we're trying to help keep the delta V down. But, we've seen some early concepts of interlunes objectives, and it looks a lot more like a bulldozer or a backhoe. It doesn't look quite like Apollo in the sense that, you have to be able to beat on it pretty hard.
Yeah, the mining industry today is becoming more and more autonomous. So I think that some of the technologies from that area might end up on the moon.
Amazing.
All right, so it's a two-parter, so bear with me. The first part is for you, Tim, and the second part is for everyone. So the first part, Tim, can you describe your storable prop lander architecture and how it supports the growing lunar infrastructure? The question for everyone to address is any thoughts on the ideal power level or architecture constraints for fission surface power systems to support both near-term and long-term lunar infrastructure?
Okay, thanks. So I think the question is about some of our ideas for an interim crewed lunar lander. So we've been working on lunar lander designs all the way back into the 70s, and we continually look at advanced concepts within my group of what's needed and what's next. And so this idea is to what is, if we need a plan B, what's the fastest thing that we could do? And I think it's very similar to what the original national team proposed, which was at its essence a two-stage lander, so a decent element that's left on the surface and an ascent element that can come back up to deliver the crew to Orion and NRHO and be reused. And you save a lot of propellant when you leave the decent element on the surface. And it's there if you want as a piece of infrastructure. And it can't be done just in two stages with today's launch vehicles, and depending on which launch vehicle it is, it depends on how many other additional things you need, like boost stages or refuelers. So it's an idea that we've got. It also means that it's a system that's in essence delivering a pretty large payload to the lunar surface, which could be used for cargo as well. And the intent there is to, okay, let's add another system that can, from today, move as fast as possible with as little as risk as possible, using parts that that actually exist right now, and that might be the fastest way. So it's an idea that's out there. We'll see where it goes.
I can only add a little bit of humor because I'm not on the surface, but why would you need to be on the surface except to talk to the orbiters? So you only need enough power for communications and navigation, and if you have an orbiter there doing it, you don't need very much. So I don't know why you need power.
Nice. So I think you want as much power as you can get, right? That's the obvious answer. Yeah. And what are the constraints? Launch mass, transfer orbit mass, landing mass, right? Those are going to govern that. So then I wonder if, what's the optimum number of reactors? Even one is hard for us to imagine just because it's a complicated thing that needs to be developed. But, where's that break point? What's the modeling say? Is it you're better off to break it up into 2 or 3, or you're better to go all as big as you can? And I think that's ripe for modeling and analysis. The other thing I would say, based on what you were just saying, Tim, is whatever you can do as fast as possible, right? So if we have something that's mature and ready to go, it may not be perfect, but we need it sooner than later.
All right, digging into a little bit on the ISRU side of things, so maybe a little bit past the infrastructure, but there to really help establish that initial infrastructure. What regolith extraction technologies do you consider most viable?
Well, I would chime in a little bit with the comment from earlier that the regolith is a really nasty substance. It's very sharp. It's very rough on everything that's ever been there. So I think Interlune has been attacking this problem specifically, and they've come up with the idea of bulldozers and backhoes and things like that that are robust and reliable and strong, and same analogs. They might even look very similar to the Earth-based ISRU approaches.
Yeah, I think the trick, and I don't know what I would recommend, is if you are trying to process the regolith, you're trying to extract something, whether it's a volatile like water, or whether it's a substance, and that's where a lot of the energy-intensive processes have to happen. There's a lot of chemistry going on in there. There's need a little power, so that's where I think the challenge is in not just dealing with the sharp regolith, but getting what you want out of it.
And as I'm sitting here thinking, we've all talking about the regolith, which is really the dust, but there's a lot of hard rock on the moon too. So techniques for drilling and mining hard rock, again, may come from the Earth or may be unique because you don't have the gravity to deal with. But
All right. What are some of the challenges to overcome to establish and operate large data centers on the lunar surface?
Yeah, so definitely power. I think the other is cooling. And in vacuum, that is more challenging to do the cooling. If you look at pictures of what the fission surface power concepts from all the different companies look like, they have these big, huge radiators to reject the waste heat. But as we move forward into the future, maybe we can reject that waste heat into the regolith as well, sort of, digging pipes. Even better would be to take that waste heat and generate more power with it. And things that we wouldn't do on Earth, because we're in this environment, I think we need to think about saving every last bit of energy on the lunar surface. And then there's the data trunk line for all of that data.
yeah, and I think it comes down to what's the data, right? Is it Netflix that we're trying to store up there? Is it scientific data? And what are the volumes, et cetera? All of our data centers use fans and forced air to cool them. So to your point, I think there's probably better ways to dump that heat or use that heat than to just recirculate it within the data center.
Yeah, my only add on this one, I think, is that if you're on the South Pole, you might have current consistent light on your outpost. If you're not, it's going to be dark sometimes. And so I was actually pondering that those data centers might actually be a source of warmth during the cold times. But then you have to get rid of the heat during the sunlight. So yeah, that's an interesting challenge, actually. Not sure I can add much more than that.
All right. Next question. I'm going to be impressed if you guys answer this one. Who will coordinate the location of landing sites, infrastructure, power generation, etc.? Will there be a lunar zoning board, for example? I also hope people from the government might be listening.
So far, we have regulations on where we can't place hardware on the surface because they're protected regions, which comes out of a description from the White House as a recommendation on disposing of lunar vehicles. For instance, Capstone. Capstone has a strategy on where to dispose of itself on the surface of the moon so as not to endanger an existing thing. So we're tracking that. I think you could certainly start there and know where to avoid. Then where do you go from there?
Yeah, the topic of lunar governance is a big one right now. I think within the Artemis Accord nations, NASA will lead a way of answering these questions. But it's not just the Artemis Accords are going to the moon. China and Russia's ILRS will be there as well. And I'm part of a group called the Global Expert Group on Sustainable Lunar Activity, run by the Moon Village Association. We've been dealing with these international questions and put out a set of recommendations. There's a new group chartered by the UN Committee on the Peaceful Uses of Outer Space. It's called ATLAC, and I forget what that acronym is. But they are at the country level thinking about these issues. So we don't have answers yet, and we know we need to have answers, and those are in development now. And I think now is fine. We've got landings happening, and they're not really impacting one another. But soon, if these visions come true, we're going to need to coordinate. We're going to need to coordinate peacefully and at the international level. So we need to establish those things.
I can add one more as well. Since I'm focused on mission design, trajectories, and the like, there's a couple places that you could land a lot of hardware. And one, Apollo demonstrated that the equatorial regions are accessible all the time. You can take a direct transfer to the moon pretty frequently and get to almost any of those locations. And then the objective for Apollo is land in the solar morning, right? The other spot is the South Pole or one of the poles. Because you can go into a polar orbit and then you have access every rev as to where you land. So there's a benefit in being at very extreme latitude or one of the equators. Now, the low energy transfer, you can go anywhere, but I presume this also has to include humans. And so humans, if they want to launch and return at any given time, then there is an astrodynamics benefit in being either near the equator or near one of the poles.
Awesome. How should risk tolerance be controlled in order to arrive at an operational lunar infrastructure ASAP? Who should define and control these requirements and how?
So I've been thinking about risk, and that presentation yesterday on the test beds and the simulators was really interesting because that's all based on model-based systems engineering, which is really tied into risk in a lot of ways. So I think having comprehensive models of what we're going to use and how they connect together gives us insight into where the risks are, and then we get to manage that. I mean, ultimately, I think whoever is, to be crass, paying for the infrastructure is going to be very, very interested in how you manage the risk, and right now that's the government. And I think the best way to do that is through highly organized requirements management, verification, a lot of the things we saw that they're doing on SLS. I would hope there's an easier, cheaper way to do that, but I'm not convinced there is. This is going to be a complex system, and managing the risk is going to take a cadre of specialists that really are just looking at the risk.
Yeah, and I think when it comes to human risk, I think that's where space agencies shine in taking the responsibility for how we're going to manage the risk and setting the requirements for how we do that. The more interesting question is, as we move into a commercial lunar economy, how do you balance that risk? And I think it's a conversation between the providers and their customers. How much risk are they going to take, and what versus what they want to accomplish? I think in the end, though, the folks who are on the lunar surface and have to close a business case are the ones who will set that risk level. And it's not easy to do, and will require a little bit of experience there to understand, well, how risky is this or that? And I think we want to get to a point where we have the right level of risk-taking such that we have successful things happening on the moon. We are building product, but we aren't stymied by being too conservative in what we're doing.
So who here in the audience would be willing to go to the moon? You guys are the brave ones. You guys are the ones that are dealing with the risk.
Yeah, I was going to say, it's going to be interesting to see who writes the first insurance policy for stuff on the moon.
Yeah.
Somebody will.
All right, this is gonna be our last question. Thank you all for being up here and having a good discussion with us. And so we're gonna end with a wish list of sorts. So if you could have one technology or capability guaranteed to be ready and reliable, waiting for you on the moon, what would it be?
Power everywhere. And so for like fission surface power, is a lot of power in one location. That's one version. But also, if we're going to be exploring and having activity at the North and South Pole and in the equatorial, we also need distributed power, probably at a lower rate. But that's the thing that right now means that you only can last for a couple weeks unless you have some source of power. And it's better if you don't have to bring that with you.
Definitely agree with that. I was actually going through The Martian in my head just now, thinking, what trouble did Mark really get into? And it was the return ride that actually gave him trouble. But he survived with power, with the ability to make food, which was a surprise. Now at the moon, I think we could get food to an astronaut or something like that pretty quick. But the return ride does come to mind as something. If you're not going to be permanent, and if you're not as brave as, or if you're more brave than me, maybe you don't need one.
Yeah, I'll go with power as well.
Well, thank you all very much. That was awesome. And a big round for the audience for your participation. Thanks for the questions. So just wanted to have a thumbs up or thumbs down for how this went. Did you like being the moderators or did you not? Cool. I appreciate that. So TAC, you're between us and the next event. Can you come introduce what's going down?
Yeah, I'll keep this short so you guys can head to lunch. Hi, I'm Takuma Hamanaka. I'm currently an undergraduate at the University of Illinois at Urbana-Champaign, and I'm majoring in aerospace engineering. I'm also here as part of the liquid rocketry at Illinois liquid rocketry propulsion team. I'm currently serving as one of the structures leads on the team as we try to build a vertical integrated static fire test stand. I want to thank AAS on behalf of LRI. We've been here multiple times, and all of us on the team have had awesome interactions with everyone here. So yeah, that concludes today's sessions in the theater. Please join us in the Student Services Building for our awards presentations and a keynote from Chief Astronaut at Axiom Space, Michael Lopez Alegria. See you at the luncheon.
Bright, be brief, be gone. That was awesome. You guys see you at lunch. Thanks.